Welcome to our continuation of our course, Computer Organization and Architecture. Today we want to look at instruction formats as we continue looking at how instructions are executed within the computer system. Previously we were talking about the instruction cycle or the instruction execution cycle, where we talked about the fetch, decode, execute cycle. And I remember indicating to you to go and look at what is an opcode. I hope you have done that. And I also asked you to look at what is an operand. All these terms are key for you to understand instruction executions and what instruction formats. So I hope you have done your research and you now have a clear understanding of these terms. So every instruction that you get in life has some form of order or some form of structure that it follows. The same thing goes for instructions that are executed in computer systems. They have some form of order or some form of structure, some form of organization that they have, so that the computer can be able to interpret them and manipulate them timelessly. You wouldn't want to be given an instruction, even as an individual, that you would take time trying to figure out what is this instruction requiring me to do. So there are various components that make up an instruction. So the basic format for an instruction is one. It should have an opcode, and it should explicitly state one or more operands. In fact, it should explicitly state 0 or more operands, which means an instruction can have 0 operands or even more. And in this instruction, each operand is referenced using what? An addressing mode. Which means we need to know where this operand is being stored, so that when we are now executing an instruction, we can quickly access the operand from wherever it is stored. Then we execute it. And for most instruction sets, more than one instruction format is what is used. And there are various formats for what? For instructions, of which today we are going to look at 3 or 4 of them. So these are the terms that I asked you to go and look at: opcode and operand. So remember yesterday, or sorry, not yesterday, in the previous video, we were talking about the execution of mathematical instructions, where we're looking at the reverse Polish notation. And we want to use a mathematical expression to demonstrate the concept of an opcode and an operand. So let's say we have 3 plus 3. When we look at 3 plus 3, the operation to be performed is the addition, which is the plus. So the plus sign becomes what? Our opcode. And the operation, for this operation to be performed, it has to use some data. So for the addition to be done in this case, we are adding 3 plus 3. So the data or the resources that enables the operation to be performed, it becomes what? The operand. So in this case, the first 3 is the first operand. Then the operation to be performed, the opcode is plus, and the second operand is what? 3. So this is what an opcode and an operand is. An opcode is the operation to be performed. Then an operand is the data to be used in the operation. So every instruction set that we are going to encounter is usually made up of what? An opcode and an operand. An opcode and operands. Every instruction is an operation to be performed and data to be used in what? In performing that operation. So we will look at 3 address instructions, 2 address instructions, 1.5 address instruction, 1 address instruction, and a 0 address instruction. So a 3 address instruction takes the form of add 1, add 2, add 3, as represented here. Add R1, which is add register 1, register 2, and register 3. So this instruction indicates that the operation to be performed is what? It's an addition. And it also indicates that the values to be added are stored in register 1 and register 2. And the result is to be stored in what? In register 3. So this is a 3 address instruction for it. An example is an add R1, R2, R3, meaning the operation to be performed is an addition where we are adding register 1 and register 2 and storing the results of the operation in register 3. That's a 3 address instruction for you. For a 2 address instruction, we have our example here. And the example we have here of a 2 address instruction is add 1 and add 2. So what you are basically doing with the 2 address instruction here is we are adding the contents of register 1 to contents of register 2 and storing the result in in register 2 here. So you can say a 2 address instruction is equivalent to a 3 address instruction in the form of add R1 to R2 and store the result in in R3. That's the equivalent of a 3 address instruction. So we are saying add 1 to add 2, meaning add contents of register 1 to contents of register 2 and store the result in in register 2. That's a 2 address instruction for you there. So we looked at the 2 address instruction. Now let's look at the 1 address instruction. And it's interesting to note that between a 2 address instruction and a 1 address instruction, you can also have a 1.5 address instruction. So in a 1.5 address instruction, the contents of register 1 are added to the contents of location B. And the result is stored in in register 1. So we said in a 1.5 address instruction, the contents of register 1 are added to the contents of location B and the result is stored in in register 1. So we add the contents of register 1 to the content of register B or register 2 and store the result in in register 1. So owing to the fact that in this instruction, the 1.5 that we are talking about, that we are saying is between the 2 address instruction and the 1 address instruction. The 1.5 address instruction makes use of, or it has 2 characteristics. It uses a register and a memory location. So we said the contents of register 1 will be added to the contents of memory location B. Then the result is stored in in register 1. So a 1.5 address instruction makes use of 2 things, a register and a memory location. That's why it's called a 1.5 address instruction. Hence, it requires a smaller number of bits than those necessarily used in other what instruction format. Then the one address instruction, it takes the form add R1. And in this case, the instruction is clearly stating that R1 refers to a register, and the register is called what? Accumulator. So the contents of the accumulator are added to register 1, and the result is stored what? In the accumulator. So a 1.5 address instruction makes use of two things: the accumulator and the register. A 1 address instruction. And we said a 1.5 address instruction makes use of two things: a register location and a memory location. So the difference between a 1.5 and a 1 address instruction is that a 1 address instruction is using a register and accumulator, while a 1.5 is using what? A register and a memory location. So a 0 address instruction refers to instructions that are used in what? In stack manipulation or stack operations. I think we talked about stack operations in our other lecture, where we were saying the two main operations that are performed in stacks are what? The push and pop operations. So now that we have looked at the various instruction formats that are there, our next area that we are going to look at, we are going to focus on what? On addressing modes. Sorry about that. I think it jumped to the wrong, I clicked the wrong slide. Because we were here where we were looking at zero address instruction. Oh, sorry. I don't think it's a mistake as such. I wanted to give you this out as homework. So maybe as I was preparing, I forgot about that and added some text there. But anyway, I think let it remain as a homework to you, so that you go and look at the characteristics, advantages and the disadvantages of complex instruction sets. Then you also look at what is the reduced instruction sets. You also look at the characteristics, advantages and disadvantages. Then we end what here. So after zero address instruction, you go and look at what? Complex instruction set. Then you look at what? Reduced instruction set. Then I will talk about what? Addressing modes as I had planned. So let's watch our next video where I'm going to be talking about addressing modes.